Hello, and thank you. Do you hear me correctly? Yes? Fine, thank you. So I would advocate that there is a yearly mandatory DNS session at LUNOG. We missed that last year. It's nice to be back again. Joke aside, yes, the DNS is at the core technology of the internet. There's, well, everything besides ping starts with DNS, with a DNS query. So it's also at the core of IT security. But as an infrastructure technology, it's too often overlooked. Well, as long as it works correctly, well, we don't think about DNS even security-wise. But we will see the importance it has today. So yes, next slide, please. Okay. So those who have faced DNS already probably know this. For the others, it's never too late to learn. What's involved in a DNS resolution are three main actors. First, the stub resolver, basically your operating system or your application that it's taking a fully qualified domain name and asking for data about it and waiting for the reply. To get this, it contacts a recursive resolver provided by your ISP, your IT service if you're in a company or in a university, or a public recursive resolver that you have configured yourself, like the one for Google, Cloudflare, or Quad9. This is the server that will actually go and fetch the information from what are called authoritative servers. Those are operated by different entities because the DNS is decentralized. So from the root operator at the very top, then by registries like RESTENA is with DNS-LU for the .lu TLD. And then by what we call second level domains like LUNOG4, for instance, authoritative server provided either by the registrar, by a DNS provider, or by the company itself. It has the ability to manage it. And the recursive resolver will query those authoritative server until it gets the proper reply. Here we see where basically have a browser asking for an IP to get the corresponding web page, and we get finally an IPv6 because hey, it's 2031, and you know that we should all use IPv6. Next slide, please. So how does DNSSEC comes to play in this? There's basically two elements required for DNSSEC to operate. The first side of the coin are the authoritative servers that need to sign their loans and publish the signature of the key used to the parent in order to build a chain of trust from the lower level back up to the root of the DNS. So that's the first side. The other side of the coin is a validating resolver. So this resolver has the signature of the key that is used to sign the root zone. This one is widely public. There are even T-shirts or mugs with the signature of this key printed. And it uses this key to validate the reply it got from authoritative servers, and comparing the signature of the replies with the keys the signature of the keys that were used to get the signatures. They're walking up back this chain of trust. And what does this validating resolver do? If the answer matches the signature, it will transmit it to the stub resolver, and the resolution is over. And if the reply is bogus, means invalid in terms of DNSSEC, it will reply with serve fail, which means basically an error. Next slide, please. So let's focus on the states of DNSSEC deployment in Luxembourg with the first part, so the validation. I've first tried to make a test using Atlas probes. Trying to get probes located in Luxembourg, trying to resolve a properly signed DNSSEC domain in the first test, and purposely invalid domain in the second test. You see that I requested 100 probes, I only got 50 of them, and basically 30 5 were properly doing DNSSEC. So that's a rough 65% of validating resolvers. But due to the lack of probes, this is not really meaningful. So next slide, please. So then next slide. Okay, thank you. So I turn myself to ATMIC, which is the equivalent of RIPE and CC for Asia and Pacific. They're using a Google-based, Google Ads-based test. So basically, they purchase ads which trigger DNSSEC queries that they can monitor. So it gives them a decent view of how DNS and DNSSEC are used globally. And here we see that if we, well, I only depicted the map for Europe, but you see that in Europe, Luxembourg is amongst the top countries having in terms of fraction of queries that are validated. We have at the top like very small country where there's probably just one ISP, so it's easy to get high number. They either validate or not. But still, Luxembourg is in the top tier with Nordic countries. And well, this is mainly due, and thanks to them, to the main ISPs in Luxembourg, so Post and Tango, that provide validating resolvers to their customers. So this really means that most of Luxembourg's customers are behind a validating resolver and could benefit from DNSSEC in their daily access of the internet. Next slide, please. So now if we focus on the other side of the coin, so are zone or domains signed? Of course, the two higher links of the chain, so the root level and the TLD level, with .lu in particular, have been reliably signed for more than a decade now, without too much harm. It's something that is really mastered either by the root operators or by ourselves. But I wanted to find if popular domains used in Luxembourg or popular domains with the .lu extension are DNSSEC signed. So I turned myself to those top domain lists. You probably know Alexa or some of them. They use quite a different metrics to define what is a popular domain. So I merged them all and try to find some interesting data in it. So I've found more than 2,500 .lu domains in this list, and well, only 89 of them, so 3.5%, were signed, and really just a few related to the financial sector and no critical or state-related domain. So the whole list of signed domain in this popular category is below. I'm sorry, it's a bit small. I should have given more consideration to those who made the effort to sign their zone. But here you can find people like Security Made in LU, Lux Airport, the university, or a lot of RESTENA hosted domains, because yes, we do sign the domains we host. And there's even, the funny thing is that even Jesus.lu is DNSSEC signed. So I don't know if you're following Jesus, but yeah, at least in terms of DNSSEC, I would recommend that you do and sign your zone as well. Next slide, please. So I've took those lists and took the top LU domains of the list in order to find which highly popular domains are signed. So if we look from the result from Majestic, we see that only 2 of them are. And what is, well, really bugging me is that neither state-related domain like public.lu or government.lu or eta.lu are signed. And we will see in later example of how some attacks using DNS tried to set up a surveillance on government agencies. And none of financial sector related domain like cssf.lu are signed as well. And we will see in another example that some finance related services were also attacked using DNS and not protected due to the lack of DNSSEC. Next slide, please. This is basically the same idea with another list. So the ranking is a little bit different, but you might recognize the same domain. And here, the same conclusion applies. Some people are doing the job well and signed their own like circle, of course, I would say. It's funny to note that DNS-LU is DNSSEC signed while VDL, so the domain of the city of Luxembourg, is not. And I'm a bit sad that Post and Tango, although they provide validating resolvers to their customers, they didn't sign their own, so they made like half the work to properly use to efficiently use DNSSEC. Next slide, please. Then the question can arise of how is Luxembourg placed in comparison with the other European CCTLDs. So, well, here the graph is a little bit small, but what is important to see is like there are like three tiers here with at the top tier, Nordic countries and the Netherlands with between 50 and 60% of domain signs. Those countries have been signing for quite long. They are even, for some of them, offer financial incentives to the people who do sign their domain. Then there's another tier with Belgium, France, Denmark, Switzerland, roughly around 15 to 20% of signed domains. And then there's the third tier, and the orange arrow tells you where Luxembourg is. So we are in this tier with 5 to 6 or 7% of signed domains. The little graph on the left, the orange graph, shows you that okay, we've increased the number of subdomains from 2,000 to 6,000 between 2019 and 2021, but still we're in the lower tier of in terms of domain signature. Next slide, please. So the question, I'm telling you to sign your own and showing you figures that say that there's room for improvements, but maybe you're interested in knowing, well, what's the purpose of DNSSEC? What does it do? What does it doesn't do? We all agree here that, well, security is confidentiality, integrity, and availability. By design, DNSSEC only focuses on integrity. This slide lists other techniques available in the DNS ecosystem for other security aspects. The idea of DNSSEC is really to only preserve the integrity of the data that you have put in your zone and that you have signed. It protects you against attacks on the resolver, either if this resolver is poisoned, so illegitimate data is injected into the cache of this resolver, or it is replaced by the resolver, which is a fake resolver under the control of an attacker, or a resolver that will be lying on purpose, like some states use this technique to prevent people to access some sensitive websites. It also protects you against attacks towards the authoritative servers, being compromised, so the same server stays, but some fake data has been injected into it, or the server has been replaced by one under the control of an attacker. So next slide, please. So I've talked about attack example. I've picked this one, which is against my Ether wallet. So this is a Bitcoin wallet, so basically a platform where people can go and check and transfer their cryptocurrency. This attack started by a BGP hijack on Amazon Web Services. So, well, no RPKI there at the time. And this allowed the attackers to reroute the packets to a fake authoritative server for the myetherwallet.com domain. And what they also did, so of course the server had records pointing to a website, a fake MyEtherWallet website that they controlled. And what they were able to do is, of course, people were logging to this fake website, gave their credentials, those were stolen, and that was the purpose of the whole attack. The cryptocurrency behind those credentials was also stolen. Here you might ask why TLS, HTTPS didn't help there. The reason is because most of those people were not using the website, but were using an application, which had the check certificate validity feature disabled. So they got fooled that way. And in comparison, how would have DNSSEC helped if myotherwallet.com were signed? Well, if the domain were signed, the attackers would have replaced the authoritative server, but would have not had access to the DNS keys, the DNSSEC keys, so they won't be able to provide or to generate legitimate signatures for the data they were serving from those authoritative servers. And in the end, this would have ended by a DNS serve fail error replied by the recursive resolver. This would have prevented the users from connecting to the fake website. They would have received an error, like this domain doesn't exist, or something like that. But in no means they would connect to this fake website that would collect their credentials. Just think about if you replace MyEtherWallet by any online banking system you may operate or use, and you would see, well, how dramatic this could be for your own money. Next slide, please. The second example is an attack called DNS espionage. This is a really, really large attack that went unnoticed for months. It targeted states, especially some governmental agencies, and was committed by state-driven attackers. The idea here is that using social engineering, they collected the credentials for the registrars of some state-related domains. And so the registrar is where you register and when you can administer some data about your domain. And with those captured credentials, they changed the delegation. So they legitimately said, do not use this authoritative server anymore for this domain, but use this other one that as attacker I control. Here again, they set up the complementary web and mail servers in order to start to capture credentials. And because here they also targeted mail, once you have the credential of a mail user, you can connect, read his mail, and do quite an extended surveillance. This is what happened. In fact, in this case, DNSSEC has helped. So some of the domains that were attacked this way were signed, and the attackers were not knowledgeable enough about DNSSEC, so they changed the delegation, but they forget to change this DS record, that stores the signature of the key that is used to sign the zone. And the only victims that had their credentials collected were those that were not behind a validating resolver. Many of them were using like hotel Wi-Fi because this was done during the holiday season, and this is how they got tricked into getting their credentials collected. So here again, so think that neither government nor ETA.LU is signed, and you can imagine what could be the consequence of such an attack here in Luxembourg. Next slide, please. I think Ms. mentioned this in the introduction. Yes, if you control the DNS, there's a lot of things you can do. Today, if you control the DNS zone, you can get a legitimate X509 certificate to do TLS, HTTPS, using something like Let's Encrypt, because the only validation here is, do you control the domain? Yes, I do. I'm an attacker. I've just taken over the authoritative server just for that. So please give me a certificate for the domain I'm just hijacking. And even the countermeasure to this, like the CAA record that you can put in the DNS to limit the authorities that are allowed to deliver a certificate for a given domain, those countermeasures are in the DNS. So if you control it, you can change that as well. On the other side, all mail-related security features like SPF, DMARC, DKIM are based on DNS records. So this really speaks for you to ensure that the data that you put on the DNS will remain integral, that its integrity will not be compromised. Hence, the requirement for signing with DNSSEC. Next slide, please. A long-lived belief is that DNSSEC is dangerous because if you fail, your services will be unavailable. And after all, that's the whole point of DNSSEC. If the signature is incorrect, you no longer have access to the services. But the benefits-risk ratio is way higher now than in the past because signing the zone with DNSSEC has become really easy. A first option is to use a registrar that offers DNSSEC as a service, like we do with our MyLU registration platform since early this year. We kindly host your zone and sign it with DNSSEC without you having anything to do. You're probably not aware that we're signing it anyway. Or if you want to have the control on your DNS infrastructure, you could do it yourself using good open source DNS software. If you use a recent version of Bind, the only thing you have to do to start signing your zone is adding this one line in the config files of DNSSEC policy default, and then restart Bind, and you're signing your zone with DNSSEC. If you're using Power DNS, you have two commands: one to secure the zone, and the other one to add some records that might be missing that would be required for the DNSSEC validation to operate properly. And even if you have a more complex infrastructure, like have the need for an HSM to store your keys, there are very good open source tools like OpenDNSSEC that we use, and we recommend to do that. Next slide, please. Then once you have signed your zone, you're probably worried about having it validated and monitored. And that's the real reason was the DNSSEC is considered harmful. You can no longer leave your DNS zone live by itself without any care. Because in TLS, or HTTPS, you're probably accustomed to renewing the certificates. In DNSSEC, the keys used for signatures can stay as long as you wish, but you have to resign your zone periodically. But to help you with that, you had a handful of command line tools, either to validate your zone, to do some monitoring on it with industry standard tools, or you even have online tools to get a view of your zone from the public internet once it is published. Next slide, please. So this leads me to my conclusion for today. I could have written takeaway in singular. This is basically just 4 words that I want you to remember. It's sign your zone now. As we've seen, the infrastructure is ready. The root and the .lu ccTLD have been signed for long. There's a lot of customers behind the validating resolver in Luxembourg. Everything is there for you to take the whole benefit of DNSSEC. There's also the appropriate tooling for you to do so. And as we've seen, IT security relies more and more on DNS and really begs for your zones to be signed with DNSSEC. And if you've done a risk analysis in the past, you probably have concluded that DNSSEC was not worth it, too complicated, too expensive. My advice would be to revise this analysis in the light of the recent evolutions of the technical solutions and the risks. And finally, is some training required to do DNSSEC? Yes, it requires a good understanding of what's happening in the DNS and a proper planning. So if you want some training, you could get in touch with your favorite registry, which happens to be RESTENA in Luxembourg. So yeah, contact me, and if some people are interested, we're ready to set up a proper training session with hands-on to help you finally start signing your zone as you should. Thank you.